This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Are you brave enough to test your application on production? And what if this application is a critical banking application? Today we'll tell you the story how my team, in a brave enough and wise enough way, applied this approach to rewrite more than 20 critical banking ETL applications and at the same time sleep well at night. My name is Dima. I'm a software engineer squeezing juice out of Java for more than 10 years. I've been working for BEC for 6 years already, and I'm a big fan of open source. Who of us doesn't like the free and cool stuff? The story. So let's get back in time for a couple of years when NFTs were the future of art and not just very expensive JPEGs. When the metaverse was expected to change our life and not only our profile pictures. So by that moment in BEC here, we had a set of ETL applications having the same characteristics, like being multi-tenant, each serving more than 25 Danish banks, working stably for more than 15 years. Some of them were pretty busy applications, processing millions of messages daily, running on premises, and what is most important, all of them were built on a proprietary third-party platform that was announced as end-of-life product by the vendor. And it means that there will be no support even if we pay. In this situation, the company has to choose whether to buy a new proprietary software, a new proprietary platform, and adopt all the applications to it, or to rewrite completely all the applications using open source. It's not an easy decision for a company, actually, because a lot of things should be considered, like costs, license agreements, legal risks, and other risks. And for us, software developers, a good open source software is the one that is easy to use, obviously, easy to extend. So as it is a banking software, the financial regulations are changing all the time. Customers' expectations are growing. So we have to be ready to extend. It's easy to run in the cloud, to leverage a modernized infrastructure. And the community of this open source product should be big and active. So after a thorough analysis, it was decided that technical stack would look like this: Apache Camel as ETL engine, lightweight, easy DSL, good community. Who of you ever used Apache Camel? Raise your hand. Some, okay. Spring Boot, I bet you're not surprised. The default option for Java application in the cloud, auto-wires everything, brews your coffee, washes your pants, and allows you to start pretty quickly. And the third is a set of BEC libraries that we have for common functionality, like login, security, finance algorithm, etc. We have a lot of projects written in Java and BEC. No wonder we don't want to reinvent the wheel each time. So that's why we have some common starters, common projects, common libraries. So having the tech stack selected, we started work with following objective: to develop a new set of applications replacing the old ones with clear requirements. First of all, it should be one-to-one migration. What does it mean? It means the consumers of our applications should see no differences, and our new applications should work in the same way as the old one. The migration should be gradual. It means that we don't want to push everything in one shot because the probability of failure will be much higher. We want a predictable and gradual migration. We believe in evolution, not revolution. A pretty wise slogan. And the third, the downtime during the migration should be minimized close to zero. So having these requirements, how the working process would look like in an ideal world. The team, these people in the middle, if you look closer, you can recognize me somewhere here. So the team takes business requirements, specifications, software documentation, tests of old application, manual test cases, as well as automated tests. So having all of this, the team creates a new application that is supposed to work in the same way as the old one. We deploy it to production, we replace the old application, and everything is fine. But it's not. What can go wrong here? Any ideas? Yes. What else? Okay. Basically, many things can go wrong. Gaps in business requirements, you mentioned, not full specifications, incomplete software documentation, tests in a 15 years old application. No wonder that their parts are at all absent. How about approaching the people who created this old application and asking the questions about the code? Good luck. Even if they're still in the company after 15 years, what's the probability that they still remember why there is a substring call on the line 267? And the worst part here, that in average in our industry, according to researchers, there are from 15 to 50 errors per each 1,000 of lines of production code. And that means that our old application for sure contains bugs. Our new one will also have it, but most probable they will be different bugs. And as we promised to our customers, to our consumers, that our new application will work in the same way as the old one, we have to migrate defects and bugs from the old application to a new application. And we don't know where they are. So having all of this, are we safe to go in this way? Maybe not really. Or maybe artificial intelligence can help us here. Of course not. The law of the universe. If you have a mumbo jumbo on the input, you will get a poppycock on the output. And it doesn't matter who is in the middle, a good old meat bag like me or you, or a new shiny LLM. And there is one more psychological trick. Maybe positive thinking can help us. Yeah? Just think positive, be optimist, everything will be fine. Yeah, we doubt it. But seriously, let's remind that we are migrating ETL applications. And what is ETL? It's extract, transform, load. That means that there is a limited set of certain input messages and the corresponding set of output messages for each application. And this fact brings us to the idea of shadow migration. Shadow migration is a strategy when we have both old application and new application working in parallel in production, and the input message that we receive from the upstream gets copied to new application and old application. When old application processed its input, the output message gets copied to downstream application, and this pinky heptagon called comparison engine. When the new application processed that message, it gets to comparison engine only. Important. Along with all the copies, the correlation ID should be passed as a header. And when comparison engine receives the flow of messages, it can match in this flow pairs of output messages by this correlation ID. And when it gets a pair of messages, it can compare them for differences and save the result of comparison to some storage. It was Elasticsearch in our case. Having the statistics of differences in the storage, a monitoring and alerting can be configured to have a better picture of what is happening. What are the benefits of this setup? First of all, nothing is changing for the consumers. They still receive the output message from the old application, and they don't know anything about this comparison engine, this new ETL applications, whatever. But at the same time, for us as a team and for stakeholders, we have a precious insight and information of how good is our new application, how is it different from the old application. And it's happening in real time and on production data. So you might be thinking right now about some technical details, how the messages gets copied and what is the correlation ID. In most cases, it's simple because the correlation ID is just some unique piece of information for each message. And in most cases, it's already present. For example, payment ID or trade ID, whatever. And even if it's not there, for example, if there are just value objects passed, then some technical ID can be used, like JMS message ID in case of MQ, or Kafka partition plus offset in case of Kafka. The copy of the message can be implemented by either transport means, like in MQ, there is something like MQ message replication. The feature is called like this. Or you can create a lightweight facade application, put it somewhere here between upstream and old application with the sole purpose to make the copy and to populate correlation ID as a header. So you might remember that there was something about sleeping well in the title, right? And essentially, the comparison engine is a good sleep enabler in our case, because having this setup configured together with monitoring, anybody who is interested in this project, the team or stakeholders, can visit the monitoring page and select the time frame and see how many messages were processed by each application and what's the percentage of differences. It can be looking like this. So here, as you can see, projects 4, 5, and 9, they processed altogether like 1.5 million messages, and there are no differences so far. On the contrast, projects 7 and 8, they look not so nice, and indeed they need some more work. So looking at this page, we can decide whether this project, this application is ready to go live. And as you remember, there was something about gradual migration in the requirement. So indeed, having this set up, we can migrate the applications one by one as soon as they are ready. And ready here means that there are no differences for a long enough time span, and we get an acceptance of the management. And if we decide to go live with some application, the migration itself is just a matter of redirection of the input and output traffic, and it is done in seconds. And the fallback is the same quick. For example, if we deploy it and we see some unexpected behavior, some performance problems, etc., the fallback is the same. Redirect the traffic, and everything is like it was previously. The talk is cheap. Yeah, that's why I will show you some code. Okay. Presentation mode. All right. This is a simplified version of comparison engine, a Spring Boot application with Apache Camel. To start using Apache Camel, you need to know two things only. The first is camel root. Camel root is an object that describes the pipeline, describes the steps of processing for the message from the source to the destination. And the second is exchange, is a message container that includes the message itself, headers, properties, exceptions. You can put here actually anything. And this exchange is flowing through the pipeline, through the root. Here we have in this application, this demo, only one root. We start the consuming from the input queue. Then we check whether the correlation ID is present in the headers. If it's not, the message gets discarded. Then there is aggregation step. Here, the correlation ID that is extracted from the headers is evaluated. And if there are two messages, here we have the completion sites too. There are two messages with the same correlation ID, they are considered like matched. And if it's not, the message still resides here and waiting for its pair. There is a timeout of 2 seconds for the demo purposes. On production, of course, we had much longer. So if the timeout reached and there was no pair, the message gets discarded. Here we check whether it was a timeout and we stop processing for this such message. And if there was a pair, it goes to these steps. First of all, the application name is retrieved from the headers. Then we detect the message format. We take two messages. Again, for demo purposes, I have only two message formats, XML and JSON. And of course, we had much more. So if the two messages are XMLs, we consider it's XML. And if two are JSON, we consider that it is JSON. Then there is a comparison running. We, depending on message format, select the appropriate comparing module. For XML, we used XML unit. For JSON, we used JSON assert. And on the next step, we just print out the differences, the comparison result. Okay, let's run the application. I have some test samples prepared. Let's imagine that we have only two applications feeding the messages to our comparison engine. I called it trade import, producing XML, and corporate events producing JSON. For each application, we have two instances, old and new, and we have three test cases. The first one is when the message gets discarded, either because there is no correlation ID or because there is no pair for this message. And two test cases when we have a pair with the same content and with the different content. Here we take these messages and send them to the input queue. They are mixed, and there is some delay introduced for some messages to somehow imitate the reality. Okay, let's run. So after the application started, we received two messages. And by the way, the correlation ID in this case was just a file name. And here it's printed. So we received two messages, no pair so far. They are waiting for them to be matched. Then we received the third message. It was discarded because the correlation ID is empty. Then we had one more, and the pair was recognized. It was from trade import. It was XML. In the meantime, there was one more message. And if you see here, the thread name that receives the messages is different from the aggregator thread. So the result of comparison was no differences. Then we received one more message. Now it was a JSON corporate events, and there were some differences. They are printed. Okay, then we received four more messages. One more pair found XML with differences, and JSON without differences. And at the very end, we have two discarded messages because of the timeout that I mentioned. That's why they are on the end. And two unpaired messages, though they were sent somewhere in the middle. It was actually the first one of them. Okay, works as expected. Whew. Let's have a look to root again. And I have a question to you. Looking at this, do you recall, do you see any performance potential problems? Okay. Yes, basically the problem is here in aggregation. So as we have many applications working and they send these multiple thousands of messages in production, and indeed there can be a delay. Yeah, we can't sync the old application and new application, and because of that, here a lot of messages can be accumulated, and of course they will occupy the memory until there is either timeout reached or a pair arrive. So sooner or later, you will see out-of-memory error. And this is something that we want to avoid. And we resolve this challenge by applying sharding idea. I will get back to slides. So we started a separate instances for comparison engine for the heaviest part of the traffic, namely the busiest subflows within the busiest applications for the biggest banks. As you remember, we are processing messages for multiple banks. And it was enough in our case because luckily Danish banks are not that big. So the next challenge that we faced was the situation when we were asked to implement the relatively big change in old application during the migration. And doing two things at the same time is not something good, yeah. And Captain Obvious advises us not to do it, of course. But if this change is unavoidable, there is no other way but to negotiate with the business, either delivery delay or the scope of the change to somehow minimize the impact. There is one more challenge that I wanted to highlight. It's about the most common cause, probably the most common cause why software development projects are failing, and it's communication. We were migrating the messages, the applications for different departments, and we had to communicate with multiple teams. And probably one of the best advices from my perspective, how to quickly improve the communication, is to apply this simple mindset: better ask twice than go the wrong way. The shadow migration approach is not limited to only ETL applications. It can be applied to any kind of applications because, in a sense, any application is just a box that somehow accepts some input and somehow returns some output. So the idea is the same. And I hope that some of you will apply this approach in your future journeys. And my journey wouldn't be possible without amazing people working with me on this project. I planned to put here some paid tribute slide with the names, but thanks to GDPR, you can only imagine their smiling faces instead. As an afterword to the presentation, I have a rhetoric question to you. Is rewriting or writing at all Java applications still the way forward? Or maybe it's time for a vibe coding instead? For me personally, this GIF is a good illustration of the current state of the vibe coding. Yeah. Thank you for listening.
And now it's your turn. And who is brave enough to start with first question? Any thoughts, any comments?
Come on.
Oh, I see first person.
Hi there. So the question is, why Apache Camel and not Spring integration? Basically, you're already using Spring.
The answer is simple. Apache Camel had a good reputation in BC, and we had some additional libraries on it, and we just reused some experience from other teams. That's why.
I see another person. Let me give you the mic.
Thank you for your presentation. I'm curious to know how you compare the database effect, or for example, in the failure case, how you compare the transaction in both of the database, in old and new one was failed, and the sequence of this stuff and effect of the database. Because on this presentation, we saw the effect of the input and output. So did you had any chance to check the database effect and etc. like that?
You mean if the application is written to database, right? Instead of
this application have any effect on the database or not when you are processing the message?
In our case, it was simple because it's a ETL application, not written to database. But even if it would be like this with some writing to database, I would run a separate shadow database somewhere below and to somehow compare from time to time using cron job. Just, okay, let's select and see what are the records and what are the differences, something like this.
Thank you so much.
Yeah, we have the third question.
Any more questions?
Yeah, there is.
Thank you for presentation. I have two questions. First one, do I understand right that you switched, so you used this shadow? But at what time did you switch? What was the threshold when you said, okay, it's good enough? Okay, we're now good to switch. Was it like 99.999, etc.? And the second one, if you had these errors, right, you could have some, let's say, high volume transaction that will not be matched, but it will be really rare, right? Like once in millions and millions. But the impact would be really high. So how would do you have some things to control that things that are not matched?
So the first question, what was the first?
What was the threshold when you decided, okay, we're good enough to go?
Yeah, it was a couple of weeks. And mostly during this time, we had almost all possible combinations processed. And still, there was a possibility that some rare event will arrive and break everything. But it didn't happen. And the second question.
About this rare event.
A rare event, yeah. We didn't have it.
Okay.
Yes. Thank you.
Okay, I see another person. Here we go.
Thank you. The question was about threshold. So you moved only when we got 100%, or it was like 99?
Yes. 100.
100. Okay. And question about infrastructure. As I see with current structure, you should have twice, to double your current infrastructure. You can't limit with some small machines or something like this.
Yes, the spending on the infrastructure was twice big during this shadow stage. And actually, the upper one, where is it? Let's have a look. yeah, this old one was on premises and this one was in the cloud. So we relatively quickly get rid of this one and stayed with only the cloud.
Any more questions?
On your example, there is a window when you collect the data from the main flow and shadow flow. And it was written in comment that if there is no matching from each other, the message is dropped. So the dropped if treated as a failure or as a success. Because it's a failure, you may have problem that there is a drift in time because one is more efficient. So if it's in reality, it's not problem because the messages may be identical, but you report it as a failure because there is a drift. But on the opposite way, it's other risk because you may ignore that there is no matching message, but the messages in true may be different. So what do you...
Yes. So that was actually one of the potential problems that we fighted for some time by simply increasing the timeout. But indeed, it could be the problem. If for example, we had a lot of dropped messages. And of course, that's why we had a kind of hypercare period when we monitored the logs and checking how many we have such dropped events, because indeed it can be false positive that we have everything green, but a lot of dropped messages. And also in statistics, it would be also visible if we, for example, expect that there is 1 million of messages, but compared to only 500,000, well, something is not good. Let's have a look what is going on. But mostly the timeout, increasing of the timeout was the remedy.
More thoughts?
So you have mentioned the potential issue with the messages not being stuck in general. So do you have any ideas how to deal with it?
How to what?
How to deal with the messages that are, the message queue is stuck and it's not getting processed, right? So the aggregation is, you're running into the memory issue. So any ideas how to deal with that issue?
So basically, when we implemented the sharding here, we implemented a kind of router that before sending the messages to comparison engine was checking, is it for the biggest bank? We had some big banks. Okay, let's drop it to a separate comparison engine. So this router was a kind of balance loader to prevent such a situation when the queue is too big and there are a lot of messages stuck. Yeah.
So just a separation of the big message queues to like routing the big message. Because okay, got it. Thank you.
Yeah.
Are there any more questions? Okay.
So in the beginning, you said that in the old system, there could be some issues, bugs. So when you're rewriting it to the new system, you will also have the same bugs. How you will find them comparing messages at the end?
It was like this. We implement the new system, we deploy it, and we observe for differences. And if we see some unexpected differences, wow, why there is this value here? And we started investigation, and indeed there is a bug in old application. And it turned out that there is a workaround already on the consumer side for years. That's why we have to port this defect to a new application. So like this.
Thank you.
Yes, so I don't know, it was mentioned about more about architecture behind, not just about the correctness of the transforming or processing the messages, but how each of this ETL application was placed in the system. Was this in containerized somehow, or have you considered horizontal scaling of this just to provide higher throughput for this?
Yes.
Yeah, and a kind of this of also architecture thinking to be more robust, or just this kind of thing.
So all the applications were running on premises, and there were simply big, strong servers. Yeah, and here we had this cloud possibility, and in most cases we haven't had the important sequence of messages. That's why we just scale pods up, and they get processing more messages. But I remember there were two actually applications where the sequence of messages was essential, and just scaling pod was not a solution. And we simply had a thick pod here, and as there was a thick application, it was a thick pod just in one instance, and it was enough. And as it appeared, it was not the most critical application, luckily.
Who would like to go next?
I have a very simple question. What are the main causes of the unmatched output messages from the comparison engine? So I can think of like formatting issues. Yes. Thank you.
Basically, this is the answer. So the main cause was either misunderstood requirement from the old documentation, or not full documentation, and we implemented it in the way how we understood and not how it should be. And plus those hidden defects.
Having done all this
I think we are closer to the smaller number. In some degree, yes.
And now I would like to welcome back on a stage Paweł Niewęgłowski, who will present Community Award to our speaker, Dzmitry.
Thank you. Thank you.